Thank you everyone for joining. Today we are going to talk about the one hook per screen rule. So I've labeled this talk, I don't know why I've called it one hook to rule them all, just kind of weird Lord of the Ringsy, but whatever. I don't know what I was thinking. You all know me, so no need for an introduction. Skip past that one. What are we going to look at today? We're going to start off with separation of concerns. We're going to talk about how you can extract business logic outside of your rendering logic. Then we'll introduce the one hook per screen rule, talk about scalable React architectures, and present how this can kind of lead us towards that path. And then we'll wrap up with some ramblings of mine that you'll be subjected to. Sound good? Nice. Okay. Let's start with architecture. This was a definition that Merrick taught me, which I actually really like. So architecture is the decisions that you wish you could get right early in a project, and that's by Ralph Johnson, who's a computer science professor. So I really like it because I think it's very practical and lets you start thinking about architecture in a kind of a different light than you might be used to. So separation of concerns. Does anyone want to have a crack at defining what separation of concerns is? You're back at CS 101. All right, go for it, Michael.
Because I've seen some of your stuff.
Have you?
Yeah.
Yeah, go for it.
So there's the idea of the model view and controller.
So that's about 7 steps ahead.
Okay.
But yes, yeah. So, but more fundamentally, separation of concerns is the idea that you don't want to write your entire program or your code as one individual solid block that has everything. You actually want to try to break things up into sort of composable, smaller chunks that play a part in a small, tiny system, that play a part in a system. And so as you add each of these together, you create a fully complete program. And so you try to separate the concerns of each component within your application. There's classic examples of this. So if you look at separation of concerns in front-end development, back in the day, a very basic web page would have 3 different components to it. You had your structure, your markup within the HTML side. You would do all of your styling within CSS, and the functionality, interactivity, and maybe some business logic would go into the JS layer. The classic CS example is the internet protocol stack, which is the idea that you've got different layers to a network for the internet, and each one of these could, in theory, be taken out and replaced with another implementation. And because these systems are so decoupled from each other, you'd be able to have a fully operating system without needing to change everything and throw it out and rebuild it. That's quite theoretical, but in practice, they're always a bit coupled to some degree, but it's where the theory stands. So where does React and separation of concerns sit? Well, for starters, the big selling point in React is that you put your markup inside your functionality. So you have a JavaScript file that can include some HTML-like elements within it to actually say what your UI should be rendering, JSX. And that's already starting to muddle separation of concerns a bit. Another example is you have so many libraries within this ecosystem to actually mix and match different parts of your front end. So you can put your styling in your functionality, which is what style components will do. On your JS layer, you'll have your styling. Tailwind is another example of this. If you use it on the website, you're probably adding your styling into your markup directly and using all of those utility classes there. Now, if we take a look at React in its fundamental state and try to point out what a simple React component might be doing, here you've got a very basic example of a button on a screen, and every single time you click it, it says, I've been clicked X number of times. So it's a very simple bit of functionality. There's nothing that's overtly complex about it. But even in this example, you can see that that separation of concerns is violated. So on the top section of the screen, you've got interactivity, you've got a state, you've got a callback to increment the counter. So that's some level of business logic that's come in. And at the very bottom, you've got both your rendering and your presentation layer there. And that's one single React component, as basic as it gets. This is fine, right? Like, it's not bad. It's quite simple to understand. Like, it's fine. But what happens is if you follow this pattern and you don't have any checks in place and you don't set any limits to it and you don't think about what you're doing, it pretty much leads to something like this. So this is from a Reddit post that I found where somebody was posting about the fact that the size of some of their files was reaching close to about 1,000 lines of code. Because you could just write everything in one go, you could just completely neglect the fact that everything is just being tightly coupled together and it's very understandable. What's the word for understandable? Unintuitive, maybe. That's a better way to phrase it. And you get these really, really insane messes that don't have any architecture to them and any pattern. So they're really unmaintainable. So that's where we're at with the state of React. You can mix things together and it can get messy. So we're going to try to find a middle ground with it. But before we do that, I want to take a step back and look at how UI frameworks have traditionally approached this issue of separation of concerns. You might be familiar with the model view controller. So MVC has been in graphical user interfaces and GUIs since the 1970s. So pretty much as soon as you had GUIs, the MVC model was invented. It's this idea that you separate parts of your UI to a model, a view, and a controller. And each bit of these are responsible for a certain section of your UI. So the model will have like actual data. So if you had, let's say, a blog, the model would have things like the articles. It'll have things like comments, so on and so forth. And then the view is actually like some visual representation. Maybe it's like how you render it on the screen of your model. And it's gotten from the model. And then the controller kind of sits in between these two. And what it does is it handles user interactions and modifies the model if, let's say, the user clicks a button to change certain values or something like that. So it sits at that interlay level. And there's plenty of examples of model view controller. You've got Rails, which was one of the most famous sort of web frameworks there, Django as well. These all follow the model view controller. So it has been a very popular model. And far before that as well, it was being used by various like app development platforms. Let's try to apply that to React now. So we saw in a common React file, you'll probably have things like business logic. So that's fetching things from a database, maybe transforming some data to match what you want in your view, configs that relate to your business, like translations and stuff like that, maybe. Then you've got rendering logic, which is the view component. So that's the JSX that you have. That's what you would be returning inside of a functional component. And maybe you'll add some styling to it. And then lastly, it's like the UI state and data handling layer, which would be the component and screen level logic and state. So maybe you have logic for if a button is disabled on a screen. That's not inherently business logic, but that's logic that's still being stored about the specific state of the app locally. Now let's take that example that we initially saw and actually make it a bit more complex. And you can see already this file looks pretty long. And all we've done here is we've taken that component, we've added a fetch request that gets an article title at the top. So all we're doing here is just getting an article name every single time that button is pressed. So a little bit of extra functionality to kind of mimic domain information that's being fetched from a backend. And pretty soon your file has gotten pretty long. So let's intersect this, sort of like dissect this and see what there is here. So at the very top here, we've got our model, so to speak. What we're doing is we're fetching an article. It's just a simple method that gets an external API, that fetches from an external API, returns the response in JSON, and then gets some stuff out of that. So that's very model-like. You're getting business domain logic. And then in the middle section of that file that I was showing you earlier, what we have is we have hooks that are doing things like handling local state of a button, maybe some text that's going to be displayed on a screen, kind of starting to act a bit like a controller if you think about it. It's the connection layer between the model which was fetching the data and then how it's interacting with the screen. And then lastly, there's a view at the very bottom, simple plain JSX. So that's model view controller like. It's a little bit different because the controller is really meant to be handling all interlay between the view and the model. So like if you change something, it would need to go through the controller. So it's MVC-ish, but not really MVC. We kind of then just took this and tried to simplify it as much as possible, because when you explain like MVC, it's actually like quite a loaded term. It has a lot of implications historically. We thought it'd just be better to have a very simple rule for it. So we came up with the one hook per screen rule, which is each component or screen should only be calling a single hook at any time. And you've probably seen this on a few of our projects, maybe some of the React Native projects that we've had. That hook is going to contain all of the UI state and data fetching, and is going to be actually making calls to other hooks to get business-specific logic. And we'll take a look and see how that would look like in this example that we had. So we're back here with this. It's that very, very long file. So first off, let's look at the controller. What would the controller be in this case? So if you look at the left side, we've got a folder structure. I've just called the screen article title screen, because all it does is click a button and it gets you an article title. And within that article title screen, instead of having one .tsx file, we've actually split it to a .tsx file and a .hook.ts file. And that hook is going to have, on the right-hand side, a use article title screen. So it's labeled to the same effect as what the screen is called. And all this hook does is you store all of the UI state and all of the data handling, kind of like a controller, inside of it. And so you just abstract away that from your actual component that's just doing rendering. So you can see at the very top of this component, we're getting articles from another hook that's called use articles. We'll look at that in a sec. And then we have things like the count, which was being put in the button, the title of the article, functions to increment the counter, update the article, and maybe refetch the article. Any use effects that you might have to populate data, so on and so forth. And at the very end, what we have is a return with an object of everything that's needed by the screen for it to be able to do its job. So by the time that you get to the screen, at the very end, what you have is you're just calling the hook. That should have brackets there, but ignore that. You're calling the hook, and all you're getting is count, title, and refetch articles. And within the return, you can see like this has no business logic. It's just taking what's been given by the hook, and it's just populating it in the UI state. Cool. Any questions so far? Because I can understand that this might be a bit confusing as well, the rate that I go through stuff usually. Good? Nice. That's the view. Again, like things like fetching articles or getting data from a database, that's quite generic. You could use that anywhere in your app. You might be fetching articles in like multiple screens in your app. That's not necessarily going to fit within this use article title screen logic anymore, because it's more generic and more abstract. So what we've done is we've created a domain folder, and within that you can split that into like different domains within your app. Maybe there's a users, maybe there's an articles, and we would put all of like the fetching logic inside of that. So again, we've been doing this on React Native projects, and it makes it a lot cleaner. So yeah, that's how we would apply it. And you see the final view here has actually got very, very minimal lines of code with it. It's quite clean. Everything is separated, and you know where you expect certain logic to live. So the benefits of something like this are described by this article that was written by one of the co-founders of Stack Overflow. He says that C++ as a language kind of always has this paradigm where you're at risk of falling into the pit of failure. And so he was saying, if you design systems that are easy to do the right things and annoying to do the wrong things, then you encourage people to fall into the pit of success. So what we've tried to do here with this architecture is to kind of create a pit of success structure so that you're not creating difficult to understand and long-winded React files. So that's one of the benefits, is that it kind of enforces a good architecture, and it's very easy to follow that pattern, so you're not having inconsistencies in your React app. Another benefit is that it actually makes following this testing trophy very, very simple. This is a concept that has been around for a while, but it's been popularized by Ken C. Dodds. If you're familiar with like traditional testing theory with software, it's usually that you follow the testing pyramid. So you start with a lot of end-to-end with very minimal end-to-end tests, a little bit more integration tests, and at the bottom you have the most unit tests. Some people have proposed an alternative, which is to do a testing trophy where you have a very bulky load of integration tests and rely a little bit less on unit tests and have maybe a few end-to-end tests to take your main flows. So this is becoming more and more popular, I'd say, in the JavaScript community. And by putting things inside of screen level hooks, what you can do is you can test some of the logic there, but not necessarily have to worry about rendering views as part of your tests and as part of your unit tests. So let's go back to that example, and I think this might make a little bit more sense. So let's say you wanted to test something here. You wanted to test if, when the screen is rendered, the count is going to be set to a certain value. That has a lot of complexities, because what you need to do is you need to shallow render a certain part of the DOM that has this component, and then assert that a certain element exists on it. You're going through this long-winded process of replicating what a React environment would do inside of your unit tests. Instead, what we would say is, don't bother testing this component at all. There's no point. Go here and test the logic for count when this hook has been instantiated. And assuming that the logic in your hook is solid and you've connected it well to your view, i.e. there's no sort of like bug in between the connection of what you get from the return here to the view, you should be confident that you won't have any UI bugs coming in. So all you are doing is you're testing the business logic, or maybe the UI state logic that's present within your hooks. And rendering or testing hooks is significantly simpler than having to test and deal with UI and shallow rendering. So what we would maybe test in this specific example is you could test the update article callback and say, if I call the update article, and maybe you'd mock the fetch response, I just want to assert that the title gets changed after the callback's been done. So much simpler than doing that and also trying to assert that the UI has been updated with very minimal risk of bugs forming at that stage, because usually you'll connect these up correctly. It's the business logic that'll trip you up. Nice. So some final thoughts to finish this off on. How are we doing with time? Quite good. I came upon this tweet when I was browsing endlessly on Twitter, and it's by Ryan Carniato. He's the creator of Solid.js. If you've been in like the JS Twitter scene at any point, you'll see that there's a certain set of people creating a certain set of frameworks that are very, very, very toxic. And they keep on trying to take credit for features that they build, and they get really angry at people who implement the same features in an open source framework. It's not a great environment to be in. And Ryan, who built Solid, is attributed with creating this concept of signals, which is the new hot topic in JavaScript land. And he has in his Twitter bio that I am not the inventor of signals. And he tweeted this after people got angry. One of the framework creators got angry about someone stealing something from them, which doesn't make any sense, but said, having been given credit for things that I didn't invent and seeing some being upset about not getting due credit, I think in times of change, a lot of new things are discovered rather than invented. And sometimes that also happens independently. People kind of land on the same functionality and the same features separate from each other. I was flying down from Scotland while I was prepping this talk, and I landed on this article by Martin Fowler. Take a look at the published date from that, 2006, about GUI architectures. I was like, this should be interesting. Let's read this. So I downloaded it on the plane, and I saw within that article that he talks about the MVP model. It's not the MVP that we're usually used to at Theodo. Neither is it the most valuable player in basketball. It is the model view presenter model. And the idea here is very similar to MVC. So the model and the view is the same, but you have a presenter that replaces the controller. And the idea with the presenter is that it is the intermediary between your model and the view. It handles all of the data fetching, and it also formats the content in a way that can be displayed by your view. And all it does is it'll handle everything going in between the view and the model. It just sits in the middle layer and has all of the UI state and all of that stuff. So it's oddly similar to this rule. And it kind of ended up with me feeling like this. Yeah, so it's nothing new, but I think it was very reassuring to see that over the years, people have iterated over different patterns, and we sort of subconsciously or independently reached a state where we reinvented or rediscovered this model view pattern along several sort of projects of experience that everyone's had, Fran and James have had, and we landed on a pattern that Martin Fowler thinks is a great sort of middle ground. And it's a pattern that you can have, which doesn't have too much boilerplate and difficulty like model view controller to get right, but it's also not cowboy style and just doing anything that you want. And he actually, in that same article, talks about the benefits of testing. He's like, oh, you don't have to like worry about the UI. You can just test the business logic and like the UI state, and that should be good enough for you. So it's very cool that we've gone back to 2006 in React World. Thank you. You don't need to follow me on LinkedIn and Twitter. But if there's any questions, feel free to ask me. I'm going to leave this one up instead.